So the last transformation we're going to look at is a dilation. So what is a dilation? A dilation is a transformation that enlarges or reduces the original figure proportionally. The center of dilation is a center point from which dilations are performed, and the scale factor describes the extent of dilation. So, thinking of a dilation, we'll have enlargements and reductions. This is very similar to our exponential functions where we had growth and decay. So first, let's look at our scale factor. Usually we represent our scale factor with a K. Oh, that's an eraser. With a K. So our rule for a dilation would be xy maps onto, and then we would multiply our K to both the x and y values of each coordinate. So xy would map onto kx, ky. For an enlargement, k would have to be greater than 1. And for a reduction, k would have to be between 0 and 1. So just like with our exponential growth and decay, with our b value, in order for this to be an enlargement, it's got to be greater than 1, and for a reduction, it's got to be between 0 and 1. Okay, so let's look at an example. So we have quadrilateral JKLM with vertices J at -2, 4, K at -2, -2, L at -4, -2, and M at -4, 2. We're going to graph the image of JKLM after a dilation centered at the origin with a scale factor of 2.5. So first, let's go ahead and graph our preimage. So we have -2, 4. So that's our J. We have -2, -2. That's our K. -4, -2. That's our L. And then -4, 2. I know this is kind of sloppy, but on your paper, try to make it as neat as you can. Alright, and then I'll just write them. So -2, 4. Alright, so here's all of our image. Now, it tells us that it's going to be centered at the origin with a scale factor of 2.5. So if we look at 2.5, that's greater than 1, so we know already this is going to be an enlargement. But we can write our rule. XY maps onto 2.5 x 2.5 y. So if we apply this rule to each of our points of our preimage, we would get J prime is -5, 10. K prime is -5, -5. L prime is -10, -5. And M prime is -10, +5. So, now we can graph our image. So we can go to -5, 10, right about there. So this is our J prime. We can go to K prime at -5, -5. Somewhere in there. L prime at -10, -5. Okay, there's our L prime. oops, prime, and our M prime is at negative 10, positive 5. Right about there. So if we connect our vertices, we end up with a similar shape. I know it's kind of hard to see on here with the not being very neat, but we have the same shape, just larger. Right? It's important to notice that if we were to connect our center of dilation and our pre-image and image vertices, we would get a straight line. Let's see if I can. There we go. Alright. So those points are collinear. Alright, let's look at another one. Quadrilateral ABCD with vertices at A 1, B 3, C -1 2, and D 1 is dilated with a scale factor of 2 centered at the origin. So let's start first with writing out our pre-image coordinates. So we have 2 1, 0 3, -1 2, and 0 1. Alright, we can go ahead and graph these. Terrible point, but there's our A. And 0 3. Here's our B. And go ahead and move this A over. -1 2. And 0 1. Okay, so this is our pre-image. We know it's going to be dilated with a scale factor of 2, which is greater than 1, so we know this is again going to be enlargement centered at the origin. So we can come in with our new rule, XY maps onto 2x, 2y. Right? Our K is 2, so to make our rule we do 2x, 2y. So, taking our coordinates of the pre-image, applying our rule, we get that A prime is 4 2, B prime is 0 6, C prime is -2 4, and D prime is 0 2. So now we'll come back and we'll plot the points of our image. So A is at 4 2, A prime, excuse me. B prime is at 0 6, C prime is at -2 4, and D prime is at 0 2. Again, I know it's kind of hard to tell with this graph not being very straight. But if we started our center of dilation at 0 0 and we connect our pre-image and our image vertices, again, we get straight lines. It's very important to make note of. Alright, so take these notes down, come in tomorrow, and we'll continue working on these.